Yo, this is Mr. O, and today we're gonna go over some important concept behaviorally of a graph, specifically about translation. Excuse me, compression and stretch. Okay, when we say horizontal, it is a shifting of a graph or a point to the left or to the right. When it's a horizontal translation, it is when the graph is going down or going up, or the point. Okay. So let's say we have we're given this graph here. Translate this 2 units up and 1 unit left. So find crucial point is to make it easier. So for example, this point here, that point, this one here, maybe that point there. Um, so all this 5 points will go up by 2. So let's say this goes up 1, 2, 3, and then left 1. Okay, so let's say this is another one here. So the new points will be up to 1, 2, left 1. This one 1, 2, left 1, 1, 2, left 1, 1, 2, left 1, 1, 2, left 1. Okay, so our graph will be similar to, there you go. That's a horizontal and vertical, no, vertical and horizontal translation. Okay, when we talk about reflection, this is reflecting across either the x-axis or the y-axis. The y-coordinate changes its sign. So if you have a -2, 3, this point here, if it reflects over the x-axis, this is your x-axis, so it's going to be reflecting here. The point will be right here. If the original problem is -2, 3, that's your x and y. What happens if you reflect over the x-axis? It becomes now still -2, and the y becomes -3. So in other words, the x will the same thing, but the y will become negative. Okay, so that is over the reflection to the x-axis. While if you have across the y-axis, the x-coordinate change its sign. Okay, so if you have -1 up to, this is a point, and this is your y-axis, the point of reflection will be across the y, which is this point here. So if this one here was -1 comma 2, this becomes 1 comma 2. So if you notice, this was the x and y, this is now the -x comma y. You change the sign of the x. Next is reflect the graph across the x-axis. So how do we do that one? So x-axis, again, we know if you're given xy, we will make it x comma -y. So we need some crucial point here. Let's say this point here, that is what is that point? Let's say -1, 2, 3, 4, -4 comma 2. This one here is obviously what, -2 comma 0. This point here is 0 comma 2, and then let's say I have here 4 2 again, 4 comma 2. So if I would like to reflect it over the x-axis, we did it a while ago here. Reflecting it to the x-axis, the y-coordinate change its sign. So therefore, this my for keeping it neat, this is my x and y. The image now will become, remember, x -y. So copy the x value, flip the sign of the y, copy the x, flip the sign of the y, copy the x, flip the sign of the y, and copy the x, flip the sign of the y. So -4, -2, -4, -2 here, negative 2, 0, still the same, 0, negative 2, and 4, negative 2. So we know the graph, this keeps going there. There you go. Very easy, right? Now we go to the next day here. Let's talk about the stretch. So, there's a horizontal stretches. Horizontal stretch, each point is pulled away from the y-axis. So what is the meaning of being pulled away to the y-axis? Okay, so for example, this graph here, this will be stretched horizontally by a factor of 2. What do? We multiply the x coordinate by the given factor, which is 2. So let's identify first a couple of points here of the this point, the red one. So we know, let me write down here to the first point here. Let's say this one here is negative 2, 0. And the vertex is 0, negative 2. And this point here is, what's that? 2, 0. And for me to stretch this out horizontally away from the y, so this is the y, away from it, it's going that side, so it's going to be a little flat. Okay, that's the idea. So I'm going to multiply the x coordinate by the given factor, which is 2. So this becomes now negative 2 times 2 is 4, 0. 0 times 2 is 0, negative 2. 2 times 2 is 4, 0. So the graph now will become, oh, this should be negative. The graph now is negative 4, 0, 0, negative 2, and 4, 0. So the graph now becomes something like this. And that's what happened when it is horizontal stretch. It's pulling away away from y axis. All right. What about if we have vertical stretch? Each point is pulled away from the x-axis. So this is your x-axis. They're pulled away. They're pushing it towards that direction there. So each point is pulled away from the x-axis. So this example, vertical stretch by a factor of 4. What do? We multiply each y coordinate by the given factor. So same thing. Let's get this point here. The points are negative 2, 0, 0, negative 2, and 2, comma 0. That's your x and that's your y. So in this case here, you're going to multiply the y coordinate by the given factor. So negative 2, 0. 0 times 4 is negative 8. And 2 times 0. Okay? So the answer of the graph this is become negative 2, 0, still the same. This will be sorry about that. Turn negative 8, 1, 2, 3, 4, 5, 6, 7, 8. And this one. So the graph will become something like this. Okay, and that's how you do the vertical stretch. Next is that we're given here perform a vertical stretch by y equals fx by a factor of 2. So same thing. When we do the vertical stretch, we're gonna what? Multiply the y coordinate by the given factor. So we're gonna multiply by 2 the y coordinate. So, but first we have to know the points. So I have this point, that point, the orange point. The orange points are negative 3, 0, negative 2, 2, 0, 0, 2, 2, and 3, 0. Remember, I'm going to multiply the y coordinate by 2 because the vertical stretch, 0. Negative 2 times 2 is 4. 0, 0, 2, 4, and 3, 0. So this will cross, or the green one will be negative 3, 0, negative 2, 4, 0, 0, 2, 4, and 3, 0. The graph will be vertically stretched. Remember, it's going to pull away from the x-axis, and that's the graph. Just to make it straight and neat there, okay? All right, so when we do compression is basically like shrink, making smaller. Horizontal, each point is pulled towards the y-axis. So it's going to be being pulled going towards the y-axis. So what we do is you multiply each coordinate by the given factor. While when you're given vertical compression, each point is pushed towards the x-axis. So it's being pushed towards the, let's say you have a V shape, this is being pushed towards the x-axis. What we do is we multiply each coordinate by the given factor. For example, here, um, perform a vertical compression by a factor of half. So again, same thing. I'm gonna get this 3 points here to get an idea. The points that I have are negative 2, 0, 0, negative 4, and 2, 0. I'm gonna multiply vertical compression by half. I'm gonna multiply which one? Since that's vertical compression, I'm gonna multiply the y coordinate by the given factor. So the y will be multiplied by half. So it will become now negative 2, 0 still. 0, negative 4 times half is negative 2, and 2, 0. So negative 2, 0, 0, negative 2, and 2, 0. The graph will become now something like this. Okay, and that's how the vertical compression by a scale factor of half. Okay, and for your, hold on.